Hey folks, how are you guys doing today? Welcome to today's talk. I'm Kai. I'm a senior product manager at Uber AI division within Uber. My product is called Michelangelo, which is Uber's internal end-to-end machine learning platform to power all the machine learning use cases at Uber. Almost every single interaction you have with the Uber app involves machine learning. When you book a ride, we use machine learning to match you with the driver, to recommend the best pickup location, to calculate the ETA, to guarantee the safety of your transaction, all the way to the customer service. When you try to order food on Uber Eats, we use machine learning to personalize your home screen, to recommend restaurants and dishes to you, and to calculate the estimated time of delivery, and so on. I use Uber as an example, but as you can imagine, machine learning and AI are being used in a wide range of products. So today, let's talk about AI and machine learning product management. A quick overview of today's agenda. We start with the definition of artificial intelligence and what do we mean by AI products. Based on the types of AI products, we have different types of AI product managers. Then we will cover how AI products differ from traditional software products. And due to these differences, what kind of skills are required for AI product managers besides all the required skills for traditional product management. And let's see how we can apply these skills to the daily job by running a case study. And then I will end my presentation with the key takeaways. Today's talk is not a machine learning 101 for product managers. We will briefly touch on some machine learning concepts, but that's not the focus of today's talk. And I'm not going to talk about interview preparation tips. Those might be in future sessions. Without further ado, let's jump right into it. So first thing first, what is artificial intelligence? How about machine learning? How about deep learning? All these buzzwords you keep hearing in recent years. By definition, AI is the simulation of human intelligence by machines, especially by computer systems, so that it can automatically perform human tasks without human intervention. A misconception is that AI equals machine learning, which is actually not true. AI can be a rule-based system where the hard-coded rules, if A, then do B, are programmed into the system. Depending on the complexity of the system, there can be tens or thousands of such rules. By chaining all these rules together, such a system can make decisions or take actions on new data without human intervention. A more efficient and flexible way to achieve AI is through machine learning. Instead of hard coding the rules, we just feed historical data, a lot of data, into the system and let the system learn the rules by itself. We define how the system should learn by coding an algorithm. Then the algorithm is run on data to learn the rules. This learning process is called training, and the outcome of training is called a model. Then the model is used for making predictions on new data. There are various types of machine learning algorithms, with one subset being deep learning, which leverages artificial neural networks to solve more advanced AI problems. How deep learning works is out of the scope for today's discussion. What I do want to mention is that deep learning is not another category of AI techniques compared to machine learning, but is a subset of machine learning. So such a statement as our product does not use machine learning, but deep learning doesn't really make sense. Actually, in real production, only 10% of the machine learning products are using deep learning, So now we've understood what AI is. Let's talk about what defines an AI product. All AI systems today are artificial narrow intelligence, ANI, or weak AI. It can only perform a certain set of tasks within a limited context. A product built based on such systems is defined as an AI product. And the goal of this product is to improve human productivities. Contrary to ANI, there is AGI, Artificial General Intelligence, which is a machine with general intelligence, much like human beings, that can solve any real-life problems. So far, AGI only exists in movies, and we are far, far away from making it happen in real life. So based on this definition, you should understand these are not the AI products we're talking about. Although it would be really cool to manage such products, these are not the things we do in our daily job as an AI product manager, at least not for now. So before we move on, I do want to point out that although AI doesn't equal machine learning, because most of the AI products today are actually using machine learning techniques, we can use these two words interchangeably without confusion. So when people talk about AI products, you know they mean machine learning products, and vice versa. In the future slides, you will see me using AI and machine learning interchangeably, so don't get confused. You can safely assume they mean the same thing here. So we have discussed what are not AI products. Then what are the AI products we're talking about? At the very high level, there are three types. Starting from the bottom here, we have AI machine learning tooling. These are the tools, platforms, frameworks, which help accelerate machine learning development. Examples are, of course, Michelangelo, which is Uber's machine learning platform, SageMaker from AWS, Vertex.ai from GCP, and we have Databricks, which is claimed to be a data platform, but they also can perform machine learning tasks. And the last example here is PyTorch, which is kind of different from the first four examples I'm giving here. PyTorch is a deep learning framework which helps the machine learning developers to write deep learning code more efficiently. On top of the machine learning tooling, we have AI services. These are purposely built AI applications to address certain machine learning use cases. For example, computer vision, natural language processing, anomaly detections, and so on. Then the product developers can embed these services into their products to solve business-specific problems. The major players in this space are the cloud service providers, such as AWS, Azure, GCP, IBM, just to name a few, and some smaller companies who focus on some niche market, such as C3.ai. And finally, we have the products which you are more familiar with and probably use every day. We call this applied machine learning products. Some famous examples here are Google Search. Well, you might ask, how's Google Search an AI products? Well, let's run it against the definition in the last page. Quickly go back here. So does it use AI techniques? Yes, it does. It actually uses machine learning. It uses machine learning to crawl the internet, index all the sites it finds. And once a user enters search keywords, it uses machine learning to rank the results and return the most relevant ones to the user. Does it only perform a limited set of tasks? Yes, it only does search, right? And within a certain context, you have to tell the search engine what you want to search for so that it can perform the search. Does it improve your productivity? I think the answer is obvious. Just imagine a world without a search engine or without a Google search. If you want to find something on the internet, you have to manually go through all the sites, find the one you need. Okay, coming back here, the second example down here, self-driving cars. Pure cutting-edge, state-of-the-art AI product, right? It heavily uses AI technical machine learning technique called computer vision. Moving on here, YouTube. How does YouTube use machine learning? It uses a machine learning system called recommender systems to recommend the most relevant or interesting videos to you so that you will keep watching and using YouTube. And on the right side, here, if you have a credit card, you have a bank account, you might have received such message from your bank. This is not generated by human. Banks processes like billions of transactions every day. There's just no way human can do this job. So they actually use machine learning to automatically detect the potential fraud transactions and send you the alert. So down here, we have Google Maps. It uses machine learning to calculate the ETA, to compute the optimal route. We have a Uber example here. And as I mentioned, we use machine learning to match the rider with the driver in real time. Then we have personal assistants such as Siri, Google Home, Alexa, which is based on the technique called conversational AI. Then last example here is how you actually unlock your phone by using facial recognitions, which is another application of computer vision. So based on the different types of AI products, the AI product managers can also be categorized into 3 areas. And based on my experience and observation, 10% of us are machine learning tooling PMs, including myself. 20% each are working on AI services, and the majority are focused on applied machine learning, which actually makes sense. There are more applied machine learning products. To understand how AI product management is different from traditional product management, first, we need to understand how AI products differ from traditional software products. I look at this problem from the following aspects. First of all, how to define success. A traditional software product is considered to be successful if it meets all the defined functional requirements. A machine learning product, on the other hand, should meet all the functional requirements and also the model performance or accuracy requirements. The best machine learning products still make mistakes. That's just the nature of machine learning. It's the model performance metrics that distinguish good ML products from the bad ML products. Along the same line, software product quality depends on your code quality. Besides code quality, machine learning product quality also depends on the data and tooling parameters used. Even your code is perfect. If you feed the system with garbage data, guess what? You will get garbage output. To develop a software product, developers usually use 1 or 2 or few frameworks. To develop a machine learning product, developers need to try many different models, libraries, algorithms, frameworks, and the dev cycle can be much longer. Software engineers build software products, but to build machine learning products, we need data engineers to collect and process the data scientists to build and train the model, machine learning engineers to deploy the model to production, and software engineers to build the whole pipeline and infrastructures. The team is just usually much larger, so collaboration and communication play a more critical role here. Software development is usually incremental and forward-moving, meaning you know exactly that the first 2 weeks we'll work on the database layer, the second sprint on APIs, the third sprint to build UI, and so on. If you run into issues in the third sprint, it usually won't affect the work done in the first 2 sprints. But machine learning development is a totally different story. You can be into the project for a month, then you realize you need more labeled data, or the algorithms you've tried in the past months just don't work. And oftentimes when this happens, you need to restart from scratch. And because of this, it's really hard to manage the project timeline for machine learning development. Last but not least, if it's a pure software product, it's usually feasible to explain the results. But machine learning products are usually hard to explain because the rules learned by the model are difficult to interpret or just not available, especially if you use deep learning, which is often considered to be a black box. Good luck with explaining the results. So due to the differences between traditional software products and machine learning products, Besides the skills for traditional product managers, things like user science, design, leadership, and so on, there are additional skill sets required for AI or machine learning product managers. And I think on the top of this list is AI and machine learning technical foundations. You have to be technical and familiar with all the AI machine learning concepts and best practices. Be technical enough so that you can smoothly work with your engineering teams, discuss trade-offs among different approaches, different models, different frameworks, have good sense of what can or cannot be done by machine learning, and also communicate with your customers to explain complex product or machine learning concepts, discuss data strategies, and support your customers whenever needed. We'll talk more on this in the next slide. Secondly, machine learning problem mapping. All product managers need to identify and define the business problem. For AI product managers, you have to take one step further to map the business problem to a machine learning problem, to map the business metrics to machine learning performance metrics. Also, not all the problems should be solved by machine learning. Deciding when and when not to use machine learning is also AI product managers' responsibilities. Next, data literacy. Data is the most crucial part of a machine learning product. Having hands-on experience or working knowledge of data and models as an AI PM is considered to be an essential skill. Do you understand how data is generated and processed? Do you know what data is required for what machine learning problems? How do you request data from your customers? And what data to collect and how? All this. Explainability. Have a strategy and proper tools to explain your prediction results to your customers. For example, if your model rejects a credit card transaction for your bank customers, you might want to understand why it's rejected, just in case you need to explain this to the credit card holder. Remain user-centric. AI product management is a highly technical position. Oftentimes, we bury ourselves deeply in the weeds of solving machine learning problems without realizing that we should still focus on our users. A good model is not a product. A good model doesn't guarantee a good user experience. So focus on the user experience as the end goal. The next skill is also important. As I mentioned, the depth timeline of a machine learning project is very hard to estimate. So how do you handle project timeline slip? Do you have backup plans? Do you set any buffer at the beginning? All these are worth thinking about even before the project starts. Lastly, risk management. What if your model made wrong predictions? And trust me, it will. What do? Do you have other mechanisms to alleviate the problem? Do you have a fallback plan? Counterintuitively, the simplest fallback plan is to not return any results. For example, when your model says 50% of the chance the bank should approve this mortgage loan and 50% we should reject it, what do? In this case, not using the model output, but deferring to humans to make a decision is probably the best choice. Another example, when you say something which is not comprehensible to Siri, what's the response? Do you recall? It would say something like, sorry, I didn't quite catch that. Could you please repeat? Again, no decision here is better than a wrong decision in this case. These are just some examples. There are better ways we can handle this. We probably can cover in the future sessions. In my opinion, these 7 skills are required for any AI ML product managers to be successful in the daily job. So before we move on to the case study, let's take a detour and dive a bit deeper into ML technical depths. Actually, instead of depth, I think breadth is more important. Going wide to touch on more machine learning topics other than going deep in each subfield. For example, as a product manager, you will probably never get asked to code a deep learning model by yourself, but you do need to understand how deep learning works and be ready to explain to less technical users at any time. I categorize the machine learning knowledge space into 5 sections for product managers. So first, the basic concepts. These are the concepts you have to be familiar with no matter what algorithm you use, what tools you are using, or what use cases you try to address. All this basic concept just apply to all this, right? Then second, different types of machine learning algorithms. What is supervised learning? What is unsupervised learning? How about reinforcement learning? And what are those? What are the applications? Then onto ML applications. What actually can machine learning do for us, right? I mentioned this multiple times. Computer vision, natural language processing, like recommendation systems, forecasting, chatbot, things like that. Be familiar with all this. And then to build these applications, how exactly does our machine learning engineer or data scientist do it, right? What is that, the whole process end to end? Starting from data collection to data ETL, then you build a model, train your model, evaluate your model, then deploy a model to production. After deployment, how do you monitor your model performance? And if your performance degrades, what do you do? Do you retrain your model? Do you collect more data? Things like that. Then the last bucket here is about ML tooling. What tools are actually available for the machine learning developers so that they can do their job easier and better? So by no means I can cover all topics here, but I hope this slide provides a general direction, which if you want to get started on ML product management in terms of technical foundations. So we've discussed a lot. So let's run a case study to apply what we've discussed to a real life scenario. I guarantee that if you are AI PM, this happens all the time, every day. The scenario is like this. Imagine that you are a PM for a world-class machine learning platform. You're working from home today and it's lunchtime. You are having some delicious, noodles. And you just got pinged on Slack by Mike, who is your machine learning engineer on your team, asking you to join a meeting for a few minutes. So you log onto the Zoom and Mike is discussing something with Jenny, with some other people in the meeting. And Jenny is your data scientist on your team. And the conversation goes like this. Mike says, we're designing a new training pipeline to accelerate DL training. Jenny replies, oh, that sounds fantastic, but I think our customers use tree-based models, not deep learning. Then Mike has some question, most are XGB. Are these partition models? And Jenny replies, yes, some of them are partitioned. But Mike thinks the customer can actually benefit from moving from XGB to deep learning. Jenny is actually not sure about that because she doesn't see there's any motivation for our users to do it. So you are eating your noodles and enjoying the conversation, then you got caught. Mike just called your name, and here comes that magical question. Kai, what do you think? So what do you do? And the people in the meeting are staring you like this, waiting for you to respond. And you turn on your camera, you look like this. What do you do? Right? So usually in this situation, I follow 3 steps. First, I make sure I actually understand what they're discussing. This is quite important. Without this, we just cannot move forward. And second, understand what they're asking. What exactly are they looking for when they ask you, what do you think? After step 1 and 2, then you can format your answers and respond or propose the next steps. So let's follow the 3 steps. First, understand what they're talking about. And here is why you need to build your AI and machine learning technical foundations so that you can actually understand the conversation, right? What is the training pipeline? What is the DL training? What are tree models? What is this XGB? How does partition model works? When Mike says user can benefit from moving to deep learning, how can it even benefit, right? Do you understand all this? If you don't worry about it, right? Ask questions in the meeting. Make sure you understand every single thing they're saying so that you can make the right decision and respond in the right way. Okay, assume that you understand all this. And the second step is understand what they're looking for when they ask you this question. When they ask you, what do you think about? What exactly are they looking for? Are they asking you to explain the difference between tree-based models and deep learning models? No, probably not. They are the expert, right? Are they asking you about how incremental training works? Again, no. So keep in mind, you are the product manager. You should be the user voice. What they really want to get out from you is that how our users use our product today and how they might react to this change, right? So based on that, this is what I think I would answer this question. So first of all, provide the user data. We have 70% users on XGB today, about 50% of them are using partition models. And it's okay if you don't have that data right there in the meeting. Just tell them you will get back to them. You need to do some research and get back to them with the data. That's totally okay. And second, align on understandings. Do not guess, right? Make sure you are totally aligned with your engineers on this topic. And after that, make proposals for the next steps. What we should do. How do we approach our customers? What's your plan? Things like that, right? That's how I would respond to this question if I was in this situation. I hope that clarifies things for you guys. And this is just my last slide for today. If you don't remember anything from my presentation today, I hope you can at least take home the 3 points. If you are really into AI product management, start building your machine learning foundations. Second, remain user-centric while being technical. Always have a fallback plan in case your machine learning models fail to work properly. Okay? All right, that's all that I have for today. Hope you enjoyed the presentation. Until next time, happy machine learning. Bye-bye.